Hello, scholars. You've come so far in your understanding of nets, triangles, areas, different things like muffins and Bambino's Triangle Mafia. All these crazy things have happened this unit. So it's the day before the test, and I just want to remind you of some of the really important things that you learned during this unit. Now, it may come as a shock to you, but math can be applied to the real world. And I'm going to show you how all the concepts that we learned this semester are really out here in the natural world, in nature, in this lovely forest behind me. I've found some clover. So one thing we learned about area this unit is that area is additive. That means you can add it, subtract it, divide it, multiply it, and you can use small areas and add them up and get bigger areas. But let's just talk about how that principle relates to clover. So say that I said that the area of this head of clover was 90 units squared. That's the area. How much would this singular leaf of the clover be? Well, if there are 3 total, and there are 90 altogether, if I divide one off, that's only going to be 1/3 of the total, and 1/3 of 90 is just 30. So I know that each of the leaves would be 30. Similarly, if I said, this one's 30, now how many would the whole clover leaf top be? I would multiply 30 by 3, because there's 3 total, and I would get 90.
Repeat after me. The formula for the area of a triangle is base times height divided by 2. I hope you're repeating it. I'm pulling another Dora right now.
So, how do we find the height of triangles? Well, let's talk about this tree right here. This tree is slanted. So if I were to say this is the top of the line I'm trying to measure, and I want to know how tall off the ground this point right here is, if I measured that slanted tree, I would get a wrong height. I would get a height that's too long. If I were to stand here perpendicular to the ground, which is the base, put my arms like this, make myself a nice straight line, I am now the height of this triangle. Why? I'm perpendicular to the base, and I'm reaching to the highest point of the triangle. This line here, yeah, sure, it reaches to the highest point of the triangle, but is it perpendicular to the base? Absolutely not. Get lost, tree. I have found this gorgeous red leaf. It's like one of the first signs of fall, and I'm going to show you how this relates to what we learned this unit. So if I wanted to find the area of this leaf, I mean, I'm a math teacher, but I still don't really think there's any formula that could find me the area of this leaf. What I do know the formulas for are triangles and rectangles, though, and luckily, this leaf could be divided into triangles and rectangles. Not perfect, because it's got these jagged edges, but let's just pretend they're not jagged edges. So if I wanted to break this down into rectangles and triangles, let me first separate off this edge, make this into a nice little triangle right here. And I'm going to, oh so sad, I'm going to rip the leaf. Now I admit, it's not a very perfect triangle, but that could be one. Then I could take this top piece, fold it down so I can rip it, and that could be my second triangle. And then I could fold off this other side, like the first one, to be my third triangle. Now, I am left with a very rough rectangle, which I would be able to find the area of. Then I could find the area of this triangle, and this triangle, and this triangle, and add them all together and get the area of my leaf. Something that reminds me of nets is the bark of trees. So if you look carefully at the bark of these trees, you could see that you could peel it off, right? And whatever you peeled off, if you laid it flat, would be the surface area of that portion of the tree. Now, tree branches are round, so it's not exactly what we were doing, but if you can imagine a square tree branch, if we peeled the bark off of that, that bark would be like a net representing the outside of the shape, the faces of that shape in 2D. This piece of bark is 2D, but the branch was 3D because the net was like wrapped around it. So Mr. Stevens talked a lot about like nets as wrapping paper, but we could also think about them as like the bark of a shape. Imagine all those different shapes, those cubes or those pyramids, as like funny shaped trees where you have to just peel the bark away, lay it flat, and find the area of it.
As you take your test tomorrow, I want you to think back over all the things that we've learned. If you're faced with a problem that leaves you a little bit nervous, just begin writing down what you know. You know area formulas, you know how to count side lengths, you know how to figure out what the height of something is. Marking down all of these things on your test paper is going to, first of all, earn you points, and secondly, might lead you to realize that you do know how to find the answer.